This is Jim McKeith with RemObjects Software, and welcome to my session on Android development with Oxygene for Java. Short agenda, what we're going to cover. There's actually a whole lot I want to cover here, so I'm going to try and move through things fairly quickly, but hopefully in enough depth that it all makes sense. The first few parts here, I have some slides just kind of explain the different parts and how they work together, and then I have a couple different examples I'm going to run through down at the end with the Hello World and a Twitter client. The times you see there on the right are as if you're watching this in the replay, and you want to jump to just a specific spot you want to see. Real quick, if you're not familiar with Oxygene for Java, hopefully you're familiar with Oxygene for .NET, which is the compiler that powers Embarcadero Prism. Oxygene for .NET bought the Object Pascal dialect called Oxygene to the .NET framework. Oxygene for Java does the same thing for Java. It brings the Oxygene dialect of Object Pascal to the world of Java. It consumes the Java SDK or the JDK. It consumes the JDK, which is the Java SDK, and any other jar file. So if it's a jar file on the web, you can just download it and consume it right from Oxygene for Java. The result, the compiler produces a native Java jar file. There is no special runtime or libraries or anything like that. And one of the reasons you would want to go with Oxygene for Java, besides the fact that you love Object Pascal and you're familiar with it, is that it actually provides a number of language features over what's available in Java. Great for each iterator support, parallelism in the language, class contracts, stuff like that. In addition to Oxygene for Java, it's actually, we call it Oxygene for Java and Android because it has built-in support for Android development because everybody wants to do Android today. We have some Android app templates. The DEX compiler for Dalvik, which is required in order to create Android applications. It supports debugging in the emulator as well as on Android devices, and it has a number of extra tools integrated to make your life easier. One thing I will tell you, though, is that this is all in beta, and so when I'm showing you things, it may or may not look like what it looks like in the shipping version. So Android development, you start with the JDK and you add the Android SDK to that, and you compile that to the Dalvik virtual machine, which runs on the Linux kernel. Now, the reason they use the Dalvik virtual machine is because they created a virtual machine that specifically targets the phone platform, the Android platform. And so it's highly optimized for the processor as well as it has the optimizations you would need to have on a limited power device. So the result is it runs really, really well. There's no slowdown, there's no overhead. You're creating a native application even though you are using a virtual machine. That's a really important distinction. A lot of people are like, oh, I don't want to use Java, it'll slow me down. No, that's not the case. This is the native application development process for Android, is using the Dalvik virtual machine. The compilation process is you start with the Oxygene compiler and it produces a Java jar file for you. And then that runs through the DEX compiler, which produces the Dalvik bytecode. And then all of that's packaged together into an APK file. Inside the APK file will be, in addition to your DEX compiled bytecode, is any resources you're using in your application. This is all bundled together, and that's what actually gets deployed to and runs on your Android device. The Android stack, you have your apps that run on your application framework, which runs on your libraries, which runs on the Linux kernel. Now, the apps includes all the apps that ship with Android, as well as any third-party apps that you would create. This is where they live, and you notice they're just the tip of the iceberg. The application framework contains all the managers that help facilitate dealing with different things. This is what you will work with from within your application quite often. It just makes the process easier of working with telephony or location and stuff like that. Now, the libraries is a little bit lower level. This is where you get access to OpenGL, SQLite, and stuff like that. Also, you'll notice down at the bottom there is the Android runtime. The Android runtime is made up of the core libraries as well as the Dalvik virtual machine. This is where it lives in the stack, is down in the libraries layer. And then lastly is the Linux kernel. The Linux kernel has the drivers that actually run the hardware. So most of the time you're not going to be diving down to this level, but it's important to know where this is at in the stack. So real quick, the parts of an Android application. First of all, you have what's called your application context. This is the app itself. It's important distinction though that this is separate from the individual pieces that make it up. So essentially this is your main application loop. So there is a class that is your application. You can subclass it and replace it with your own class if you want to, but this is the application itself. Now the application may contain, or actually will always contain, an Android manifest, which just defines the parts of the application, what permissions it needs and stuff like that. But it may contain one or more activities. Now you can think of an activity as kind of like a window. It's a single task that the user is going to do. Now this includes both activities that you see are full screen windows as well as the widgets that sit on your home screen. Both of those activities. So your application may contain one or more activities. Now an activity is made up of a class as well as a layout file. Now a layout file is an XML file just like the Android manifest is, and you actually can have multiple layout files that make up a single activity. In our Twitter example, we'll look at that. You're also going to have a string resource file, which is another XML file. This is where you're going to put all your strings at. There's actually other things you might put in your strings XML file, colors, arrays of values and stuff like that. Basically, it's a place where you can define resources. The great thing about that is that it gives you the ability to swap that out later for internationalization, for example. You're also going to contain drawables. Now, this is any graphics you're going to use. By default, it has your icons that you're going to need in your application in there and the templates, but you can add other graphics that you're going to use as well. The other things your Android application can contain is what's called a service. Now, a service is something that runs without UI interaction. Now, it may pop up some toast, which is a little pop-up message or something like that, but a service is always running. So where this gets interesting is your application can start and create a activity, and the user interacts with that activity, and then they switch off. And that activity, based on memory requirements, may be removed from memory. But the service itself and the application context can continue to run in the background and work. And then when something happens that you need user interaction, the activity will pop back up again. We're not going to go into services today, but they're important. I wanted to make sure you're aware of them. Same thing goes for broadcast receivers. Broadcast receivers are the way your application can interact with other applications in the system. For example, you can have a broadcast receiver set up to handle an incoming phone call or a text message or something like that, or maybe a link being clicked on or something like that. And then also content providers, which are a way that your application can publish data to other apps. For example, the preferences in Android are published through content provider. So the preferences activity that you see is interacting with that content provider. What that means is another activity could provide the user interface for the preferences because they're a content provider that's behind the scenes. Now, services, broadcast receiver, content providers, not going to go into those today. That's why they're kind of grayed out a little bit there. Also, your application can have other classes in it that could do various things. So everything doesn't have to be an activity. Now, sometimes your activity needs to talk to another activity. Now, that activity might be in another application context, or it might be in your application context. And the way that happens is through what's called intents. So an intent is sent from one activity to another, and then that activity responds to that intent. And you can actually create a situation where the new activity responds back to the previous activity. Now, the user is going to see a new screen come up, and they're going to hit the back button on the phone or the Android device to go back to the previous activity. So, and we'll talk a little bit about intents. So there you go. That's an overview of the parts of an Android application. And with that, we will jump into some demos. Let's go ahead and create our first application here. We want to select Oxygene for Java, Android. Now, right now, I just have one template here. There will most likely be additional templates when it ships. Like I said, this is in beta. A number of the things you're going to see here are not as they're going to ship. So just so you know, there will probably be additional templates, at least for a widget would be my expectation. No guarantees. Go ahead and give our application a name. I'm just going to leave it with the default name here. And here is our application. So you notice we uses java.util, and our references over here is to an implicit reference automatically to the JDK, but we also have a reference added to the Android framework for part of the Android SDK. So I'm going to go ahead and expand this out here and show you the different parts that are included in this. First of all, this is the Android manifest, which I mentioned before. This is the header that tells what your app's going to do. This defines your activity, the main activity right here, which, see here, it's attached to main. This also defines the name of the package and stuff like that. So this is really important. Most likely you're not going to be needing to come in here, but if you do need to modify the manifest, you can come here real easily. Then we have our main activity that was created here for us automatically. This is the class file that goes behind it, and then this is the layout file, the XML layout file. This XML defines the layout of the application. There is a tool I'll show you here shortly called DroidDraw that makes it really easy to work with this. You can also just edit in here directly. For example, if I want to put in a additional text view, which is like a label, I could do that here, and it has properties. So you can edit this pretty easily in here. Or I'll show you DroidDraw here shortly that makes it a lot easier. It gives you a graphical interface. And I will tell you that if you're using Eclipse to develop Android, which is the recommended by Google approach, they do have some tools in there that are kind of like DroidDraw, but my experience with using them is they're not very reliable, and they tend to be kind of slow. I was really frustrated with them, and so I found myself wanting to edit XML quick right away. Also, it's important to keep the XML in mind because your applications your interface needs to be able to deal with different layouts because the Android has a lot of different resolutions it can be running on. And so it's important to look at the XML, and that way if you're writing at the XML level, you're more likely to create something that will look right on all devices, or look better on most devices at least. Let's put it that way. So I'm going to run through this class real quick here for you. We override this onCreate here. And this is where you're going to set the main stuff up in here. And so the first thing it's going to do is it calls content view equals r.layout.main. Now what this R here is a reference to resources. So resources, layout, main. See that? Main, layout, resources, R, layout, main. What that's doing is it's attaching this XML file to this activity. And it's a process called inflating. And so it actually is going to create the interface for you at that point. Now, here also, we're going to assign a button. And so this is the process whereby if you want to grab a view, now all the widgets in here are called views. They use views and widgets interchangeably, but coming from Delphi, we're used to calling them controls, but in Android, they're called widgets or views. The technical term is view. So we're going to say find view by ID, and we're going to say r.id.myButton. And so in here, we have this right here. It says the ID, and then this prefix is what all your IDs are going to be prefixed with. And this is the identifier that we use there, myButton. So r.id.myButton is how we reference that. And then we're going to assign a click listener. So this is the syntax you use to assign an event handler. In this case, it's called a listener. So here we have a button click event, and we're just assigning it here to this. This is referred to as inline interfaces. That's the way Java handles event handlers. So then in the button click event, what we're doing is incrementing a counter, and then the view that's passed into us is the button in this case. So we're casting it as a button. We're referencing the onText or the text property, and we're setting it to this formatted string. Now this r.string.myButtonText2 comes from this strings XML file here. So the strings XML file here is where you define all your strings you use in your application. This first one here, app name, is actually the name of your app that's going to show up. So we're going to call it Hello World. Then we have button text and button text 2. Now this is a formatted string that's being referenced here. And it's using count, and so it's formatting it to create a indicating how many clicks it's had. And then in this main XML, the button's default text, we'll see it has this @ string. And so that's a reference back to here, my button text, to say click me. So that's what that is doing there. And I'm going to add some additional code here before we run this. And we're going to say if count is greater than 5, then we're going to display a toast. Now, a toast is a non-modal message that you can pop up and display. They pop up like toast. That's why they're called toast. So this is what the syntax would look like. We're going to call the toast class, and we're going to call the make text method on there. And we're going to pass in our context. Now, the context is the class that we're in, or the application context. So we can either pass in get application context if the toast doesn't exist in an activity, but in this case, the toast exists in an activity, so I'm just going to pass self. And then we're going to pass in the string we want to display. So we're going to say hello world. Because where would a demo be without hello world, right? And then we're going to say how long we want the toast to display. So the toast can be either display either length short or length long. Now these are defined by the user in the Android preferences, and so just depending on how long you want to be up there, I'm just going to do length. We'll leave it length long, just because this is a good demo. And I'm going to take the results of this. It's going to create a toast object. Now normally you could take that object and save it and do something else to it if you wanted to, but I'm just going to go ahead and just call show on that directly. Okay, so we'll go ahead and build this, and if everything went correctly here. Oh, this is telling me the case for identifier doesn't match the original case. That's a warning. You can turn that off, but I'm going to go ahead and click the Fix-It wizard here and have it correct that case for me. Fix-It wizard's great. It does spell checking on your thing. So if you mistype format, for example, it'll say, oh, did you mean format? And you say, yeah. Basically, anytime the compiler would say, hey, did you mean this? It will give you the option to fix it automatically. Great, cool feature. I love it. And let's go ahead and run it here. I have my Android emulator going here. And the application comes up here. It's running in the Android virtual machine. I've actually set up, it's called the Android emulator. A couple notes about this. I'm running a skin on here because I don't like the default skin. And also the Android emulator actually is emulating the hardware, which is different than the iPhone simulator or the Windows Phone 7 simulator. So the difference is that the Windows Phone 7 and iPhone actually runs faster, but in my experience, I think this actually runs a little bit slower than the hardware. And again, it depends on which hardware you're running it on. So when you're testing here, keep in mind it may actually run faster on the actual device. So we'll go ahead and click the button. So it updates goes through here, updates the count, displays the updated text. And as soon as I get to 5, it displays, or 6, it displays the hello world. Now that's a modal display. So you see it faded out, came back again. So there is no modal pop-up boxes. Well, I guess you could make one by another activity, for example. But the toast is a non-modal display. And like I said earlier, you can have toasts pop up from your service, so they can pop up from within the background. So there we go. There's a quick introduction to hello world in the Android. If you're not familiar with Android, you can play with the simulator here and kind of get the idea of it here. You have this large virtual desktop, and you can click down here and get to all your applications. So once you've deployed the application, you can see it's running here or this is where it's available from. You can launch it manually. And it's still running in the background. So as I talked about before, if I was to close this and then launch some other applications, enough other applications, it would eventually stop running in the background. But it's still running in the background. So if I go in here again, there it is, still running. So it's going to show you some tools to help in your Android development. The first one I'm going to show you, as I mentioned earlier, is called DroidDraw. DroidDraw is a free open source application. You can download it from droiddraw.org. You have a palette here of widgets you can download. You can change your root layout. So I'm going to go with a table layout here. And with the table layout, you add these table rows to it. And then those table rows, we're going to add, I'm going to put a text block in here and ask which layout I want. I'm going to put it in the table row, not in the table layout, which is the parent of the table row. So I put these text views in here, which are essentially labels. Then I'll add an edit box to each one, an edit text. Now the way this works is there's automatically a column here. So if I change the width of this by adding more text to it, because the width is set to wrap content, so it's going to be as wide as it needs to be, and say hello world, then it bumps all of them over because they're all in the same column. You can also add another one here, and I'll put a edit text in here and go to properties and say column span 2. And so now you see this one, well, they're all flushed right there, but this one is allowed to be wider, as wide as 2 columns. So if I make these individual ones wider here, then that'll behave the way I expected it to. But anyway, that's the way this works. The easiest way to deal with this is you come in here, grab your XML and paste it in here and hit load. Or you can go file, open, and open up the XML file. Now you notice it has the click me button here. That's because I actually loaded it here ahead of time. I forgot that I had loaded this. If you go to project, you can load your string resources, which is this here. If that's not loaded, then this button, which the text is actually, substitute the text in, but the text is actually the my button text. So you can use your string identifiers and pull the strings in from your resources there to do that. This is in beta. It's free. I found it works pretty good. It works better than, in my opinion, and from others I've heard as well, it works better than the Eclipse plugins that are provided as far as interactivity and just more reliable. It's a good way to come in here, see the widgets that are available to you, and actually kind of see what they look like and say, oh, yeah, I want a radio group with some radio buttons in it. And drop them in there like that. And then when you're done, you hit generate, and there it is. You can either file, save, and save it back to it, or you can copy this and paste it in here. So that's a real quick on DroidDraw. Here's our super simple Twitter client demo for Android. You'll notice I'm making use of the Winterwell JTwitter client library. This is one of the great things about Android development and using Oxygene for Java is you can take advantage of the entire ecosystem of Java libraries out there. Most of them are open source or liberally provided with very free usage. So the JTwitter is a free open source library. It's LGPL, which means I can use it in my application without impacting the license of my application. So what I have here is my main activity is actually a list activity. And a list activity is one that has here I'll jump to the layout for it here, and you'll see I have this list view on it. So this is a list view that will get a list item layout attached to it. And so this is going to be a list. This list view will be filled with these list items, and the user can scroll through it. Now, if we go back here as well, we'll notice I have a top bar up here at the top, which is going to be the bar where they type in the name of the user they want to load the timeline for. And then we also have this empty item, which is what's going to be displayed when there are no items in there. And you notice this is pulling from my strings list to what's going to be displayed in there. So this is a text view. It's going to show a string that says no items here until there are items in the list view. Once there are items in the list view, it will be a list of these items. Now these items, we have basically just 3 text views here. It's going to have a large line with the message, an even larger line with the screen name. Here's the message. here's the screen name, here's the footer. So it's kind of backwards, but you know what? The order is not what's important. The order here is not what's important. It's the way it's told to be laid out. So I'm using a relative layout here, which is a really nice layout. So right here it just says this layout is below message, and that's how it's laid out, is order by telling each view which view is relative to. This is a great layout when you want to have things laid out a certain way and not have to worry about exactly what size it's going to be. So back here in our main activity, in our create, in order to do a list view, so I have a click listener on my list view, and here's regular button handler, which we saw that before, but this is what sets up the simple adapter. So the simple adapter is what's going to bind the data into the list view. So the way this works is we provide the context, which is the ourself, the class that we're in, and a list. So this list is up here, there's right there. It is a list of maps of string to object. Okay. And what we're going to do is this list is going to hold what we want mapped. Okay. So this is our data source essentially here. And then we tell it what layout to use, which is that XML file I just showed you here. And then we provide the keys for the hash map. We're specifying three keys here: screen name, message, and footer. And those keys, when found in this list, will be applied to these controls: screen name, message, and footer. Now you notice these are IDs for views, which are in here: footer, message, screen name. So what we're saying is that when whatever gets assigned in this hash map, which is a key value pair, or a set of key value pairs, whatever is assigned to screen name gets put into this view. Whatever is assigned to message gets put into this view. Whatever assigns a footer gets put into this view. The fact these are the same names here is for my convenience. This could be any string here. This could be a GUID, as long as below, when I add the items to the list, which I'll show you here shortly, they're match up. Also here I created an options menu, which I'll show you how that works. It's just another way of providing user interface elements. And so this is creating the options menu, and this is when the option menu is selected. So it's a different way they can refresh. And there's a refresh button at the top that calls refresh. This is the refresh mechanism. We're going to hide the keyboard and update the feed, update the timeline. Here's the code to update the timeline here. We're just calling into that JTwitter, or creating an instance of it, setting the maximum of results we want to have. Let's go more than 5. We'll go to 50. And whether or not we want to include retweets. And we're also going to grab the user data from that user. So this is how we get their image. And then I have a method here that's going to download the bitmap. And we're going to assign that bitmap to the profile image, which is in that top bar. Here's where we get the timeline. And I'm storing this in the app context. Now the app context is the application object. And in order to do that, I actually need to have a custom application object. So I created this custom application class here. And all it does is it descends from, or the Java lingo is extends, but essentially it descends from the application. And it has two properties here: timeline and the current tweet. And that's just a way of being able to pass complex data types or objects between the different activities I'm going to be dealing with. So when I descend from, or when I'm using a custom application class, I have to specify that in my Android manifest here. So in my Android manifest, right here, you add this line here, Android name dot custom application class. And so that's the name of the class that we just added here. Also, while we're in here, I'll point out that I did add the details activity here, because we're going to have a detail that's going to show up details on the individual tweets, as well as requesting permission to access the internet. And I spelled internet wrong there. Internet. There we go. So this is how you specify in the manifest that you want to have access to the internet. And so when the user installs this app from the App Store, it'll pop up and say, hey, this app wants to access the internet. And that's how it knows what your app wants to do. So if you do not specify this and try to access the internet, it'll fail. So if you're trying to access the internet, it doesn't work. That's because you did not specify this permission in here. And we'll go back to our main activity. So we're getting that timeline. We're storing in the app context timeline collection there. And then this is where we're going to spin through each of those timelines. And for each one of those, we're creating a new hash map. Now remember, here's a list down here at the bottom, which is our data source, and it's a collection of these hash maps. So we're adding to the hash map the item is going to have this screen name. So this is the string we specified up above, and it's going to contain the screen name from the status. The message is going to contain the text from the status, and the footer is going to contain the created at, which is the date of the tweet. And we're also adding in a additional item in here. Now, because this is a string and this is an object, this can be anything here. These happen to be strings, but we're going to add in the status. So this is actually the status object. And that way it makes it easier for us to grab the status later and put it into and pass it between activities. Okay. So what I'm doing here, one more time, is this hash map is a key value pair of the string that identifies what we want to have in the screen name control is going to contain this value. And we're going through each of those. And then we have an extra item here. This one's not mapped to any controls, but that's okay because it'll just be ignored. And then later we can pull it out when we need it. So once we've done that, we just put that item into the hash map or into the list, which is our data source. And once we've spun through all of those, then we notify the adapter that the data set has changed. And that way it knows to redraw itself. When they select an individual tweet, this is the detail on click event handler, and it creates what's called an intent, which remember I told you before, intents are what you use to communicate between activities. Now you can actually add extra data into an intent to send simple data, bits of data back and forward. And if I wanted to break it out and send the individual fields from my status through the intent, I could do that. But instead I wanted to send the whole object. And so what I do here is I get the item at index. So index is this item they selected from the list, and I set that as the current tweet. Okay. And then I say start activity details intent. And so that's going to send this intent to detail activity. So this is the class for the detail activity. So it knows where to go, and it's going to send that intent. There's also syntax you can use if you want to get a result set back from that intent. So there's a lot in there, but I had to get through it quickly. And let's go ahead and run this. Here it comes up in the emulator. So this is our top bar here. So right now this is our empty text that we have that displays only when there's nothing in the list. And we'll select, we want to say RemObjects. And we hit refresh. One thing about this is I did block the main thread, which if you block the main thread for more than roughly 5 seconds, Android will pop up and ask the user if they want to kill that. So if you're doing this in a production application, you'd want to put that in a separate thread, which there are, and Java has some mechanisms to make that really easy to do. So here's the image I displayed there by pulled from the user profile, and here's the list of all the tweets, which we can scroll through. So I'll select this tweet here. And this is the details activity, which I could give it a meaningful name, but I didn't. This is the ID of the tweet, when it was created, when it was replied to, when it was, how many times it was retweeted, the source, which was sent by Twitter for Mac, and the actual text of the tweet. So now, since I've moved into this activity, I can use the back button to go back to the previous activity. And this is how I access the context menu, which I added, which refreshes the timeline, which won't show us anything new because nothing's changed. But there you go. That's our simple Twitter application for Android, written with Oxygene for Java. I hope you've enjoyed this introduction to Android application development with RemObject's Oxygene for Java. If you'd like more information on Oxygene for Java, you can go to remobjects.com/oxygene/Java, where you can pre-order it now and sign up for the beta. The expected ship date is sometime next month, so not very long now. You can also learn about both Oxygene for Java and Oxygene for .NET at wiki.oxygenlanguage.com, and there are also videos available at remobjects.com/TV/oxygen. Probably this video or parts of this video will be available there as well, and there are other videos on Android as well. One thing about the wiki at oxygenlanguage.com is there is a Android primer there that walks through a lot of the steps we covered in here. And the code from this session will be available through the wiki as well. There'll be links to it from there. So you can go there and find out more information about Android development and Oxygene for Java. If you have any questions, please do email me, jim@remobjects.com, or you can follow me on Twitter. Hope you've enjoyed this, and I look forward to hearing from you.